Uh, Let us start again. This lesson is the last lesson in our program. It is chemical reaction, and it is the most important chapter for this year. This chapter will continue with you for the next years. The chemical reaction, as we said yesterday, chemical reaction is a chemical change during which substances are consumed and disappear. These substances, where some substances, where two or more substances, okay, react together, طبعا are consumed and disappear. These substances that react together or that are consumed during a reaction are called reactants, and the others that are formed or appear are called the product. What we have to explain is what do we mean by chemical change. Chemical change means the change in the nature of the substance, change in the properties of the substance or the identity of the substance. The substance change into many substances that are different in nature, properties, and identity. For example, as we said, burning of food, digestion of food, oxidation of metals like rusting of iron. Okay, all of these are examples of on chemical change. While the physical change, it involves only the changes in size and in shape. Example, tearing, if you tear a paper into two pieces, they will not be different in properties. Both will be papers. Cutting wood, if you cut a piece of wood into two pieces, nothing will be different. First of all, we have to speak about evidences or signs of a chemical reaction. How can you know if there is a reaction or not? If you mix two substances and you show a color change or a release in a gas or formation of a gas or change in temperature or formation of precipitate, then we say that a chemical change is occurred. If you want, we can see a small video. Okay, we can watch a small video about this example. These examples we are going to make it in the laboratory in the school. You can show it as in a video here. Okay, a short video. Lead nitrate plus potassium. Here we have a substance called lead nitrate in this big test tube. And here we have potassium iodide. She took some of this. We took some of potassium iodide and we added it over lead nitrate. You notice here that a yellow precipitate is observed, is formed. Here we indicate, or it is indicated that a chemical reaction has occurred. This yellow is a precipitate, a solid. Temperature change and gas produced. This is the other two evidences. The temperature is 20 here. Okay. Before mixing the two solutions, it was 20. Baking soda and citric acid, like citric acid is the acid of the lemon. Okay, they are, if you observe here, we have bubbles of gases, release of a gas that indicate this reaction is, there is a reaction is occurring here. And then there is a release of a gas. Baking soda releases carbon dioxide gas. Baking soda, you know, it is a baking powder. We have to observe the temperature now. Temperature is decreased. It was 20, it decreased to less than. Change in temperature. Okay, there is a change in temperature, decrease in temperature. Some reactions give a raise in temperature. Testing gases like oxygen. Potassium iodide and hydrogen peroxide. Both of them can be found in our homes, in our houses. Hydrogen peroxide is a sterilized substance. Here we have oxygen gas is released. How can we identify this? If we have a red hot match, it will relight again. Okay? He's repeating. Okay? You observe that lamp, this stick is relight again. Okay, due to the release of oxygen gas. Okay? Oxygen gas can relight a red hot match. It's putting it off, then it relight again due to the release of oxygen gas. Okay. Let us continue the chapter now. Chemical reaction. After that, we have to start, okay, chemical equation. A chemical equation, any chemical reaction can be represented by a chemical equation. A chemical reaction is represented by chemical equation, by an equation. This equation is called chemical equation. During chemical equation, we use what? We use symbols of atoms and formulas, okay? A molecule of elements and compound. Let us say this word equation, hydrochloric acid is added, okay, this hydrochloric acid solution is added over sodium hydroxide solution to produce sodium chloride solution plus water and plus heat. These two substances, if they are added, they release heat and gives to other substances. In order to simplify this reaction, okay, and simplify the dealing with such reaction, we transform the chemical substances into formulas. Hydrochloric acid can be expressed as HCl, sodium hydroxide and AOH, sodium chloride and ACl, water H2O plus heat. Okay, what is the importance? Generally, A and B are reactants, C and D are on this reaction, and here we have HCl and H2O, they are called reactants, and NaCl and H2O are called products. Okay? Okay, is it clear? These are substances that
Yes.
are reactants that disappear during the reaction. And these are called products that can appear during the reaction. Okay, generalize. Generally, we have a substance A, a substance B, a substance C, and a substance D. A and B are called reactants, C and D are called the product. Small a and small b and small c and small d are called stoichiometric coefficient. And here we can write in each, sometimes we write small letter below each substance. L means liquid, S means solid, G means gas, AQ means aqueous. Okay. Here, as we see, if S is a solid, 2HCl is an aqueous. What do you mean by aqueous? Aqueous means that a substance is dissolving in water, forming a solution, aqueous solution. FeCl is a solution. H2S is a gas. Later on, we have to learn how can we write an ionic equation. Not now. Okay. Next topic. This topic is this subject is we have to start it now. Later on, we can start writing the equation. Okay. Low conservation of mass, or it's called also Lavoisier's law. Okay. Okay. What do you mean by Lavoisier's law? It means the conservation of mass. As we see here, this uh, this law can be verified by an experiment. Okay. We have a substance called barium chloride, BaCl2, and substance called sodium sulfate. Here, barium chloride is put in this small test tube, and sodium sulfate is put here. All of them all together with the glass, the mirror flask with these two substances have a weight 300 gram, 0.23 gram. After shaking, like shake it, okay, after closing the mouth of this mirror flask, shake it, the barium chloride will get down and react with the sodium sulfate. We will observe a barium sulfate precipitate is formed here. This test tube was empty now. Okay, and the substance formed is barium sulfate. If we look at the mass at the end of the reaction, we will find it is the same. Okay, 300.23. What does this mean? Okay, and why? This mean that, according to this mean in a chemical reaction, number of mole is conserved. Okay, the law of conservation of mass, okay, the law of conservation of mass states that mass is in isolated is neither created nor destroyed by chemical reaction or physical transformation. This law states that the mass of a product is equal to the mass of a reactant. This is the statement. This is the statement shortly. Okay. Okay. Always a mass of reactants equal mass of a product. What we put in the flask, we will obtain it at the end. At the end, and طبعا in different substances. Why? Why the mass of reactant equal to the mass of product? The answer will be the number of atoms is conserved. Why is the mass conserved? Because the number of atoms of each element is conserved. No change in the number of atoms. For that, we can apply the balance of equation and under this. Okay, we apply the balance of equation under this subject. Because in order to get conservation of mass, atoms must be equal. Okay? This statement, I know why should we have why should the mass be conserved? We say because the atoms should be equal on both sides in a chemical equation and reactant and the product. Okay? Okay. This is the answer. Okay, Noah?
Yes, it does.
Let us start apply the balance. If you have such a reaction, and if you have to balance it, you should know here that we have reactant side, we have always in a chemical reaction, we have substances. Each substance has a molecular formula. Okay, هاي molecular formula. Okay, وهاي molecular formula. These molecular formulas are constant, no change in their composition. What we have to change, what we have to add, we have to change what? We have to change the coefficient. If you have here three carbons, here we have just one carbon. We have to multiply by a number. This yellow box is conserved. What we have to multiply the molecule of carbon dioxide in order to get three carbons. Here we have C3 H8, we have to multiply this formula by 3 out. And no change inside the molecule. Only the change in the number of atoms, the number of the coefficient number. Then we multiplied by 3. We multiplied by 3. Then H3 is 3H8. H8, 8. We have 2 here. We have to multiply by 4. 4 times 2, we get 8. Finally, we have to count for oxygen in order to balance the oxygen. Okay, how many oxygen we have? Here we have, okay, here we have 2 multiplied by 1 here. Okay, here we have 3 times 2, 6 oxygen in the first molecule. In the second molecule, we have 4 times 1, 4. The answer will be 10. If you have to multiply here by a number, what number should we multiply to in order to get 10? We have to multiply it by 5. If you don't know mentally, you can write here we have x. We have multiplied by x to have 2x to this side equal to 10. What is x equal to 2 and equal to 10 divided by 2, we get 5. We multiply, so we remove x, and we write, okay, we write 5. Let us continue balance. Okay. Then on in the element reactant products, okay, this table is not necessary to be done. Okay, we can done this by trial and error. Okay, يعني انه مثل ما عملنا another equation. هاي equation is finally like this. Let us take another equation. Oh, before start balancing, let us apply the law by masses. Given the following balanced equation, we have two times. This is the coefficient. It's a stoichiometric coefficient, and this is the formula. Okay, formula unit KClO3, and we have here 2 the coefficient. Okay, multiplied by KCl. Here the coefficient is 1. Okay, the mass of this side must be equal to the mass or total of this side. It is given that 12.25 gram of this potassium chlorate. أخذنا نحن 12.25 gram of potassium chlorate introduced into an Erlenmeyer flask and heated to be decomposed completely. Okay. After a certain time, or at the end, the number of mole of KCl obtained is 0.1 mole of KCl. Calculate the mass of KCl, given M of KCl is 74.5. Okay, of course, we write that if we have mass equal N times the molar mass, as you know that the number of mole is always equal mass over molar mass. If you are given the number of mole and the molar mass, how can you get the mass? We must cross multiply number of mole per molar mass. 0.1 times 74.5, we get 7.45 gram. Okay, next question, deduce the mass of oxygen gas released according to the law of conservation of mass. As we said in the last law, mass of product equal mass of reactant. Mass of KCl plus mass of O2 should be equal to the mass of KCl. Now, we have the mass of KCl given, KClO3 is 12.25, and we have the mass of KCl, we have calculated. What will be with the mass of oxygen? We say the mass of oxygen is equal to mass of KClO3 minus mass of KCl we subtract, we deduce the mass of oxygen released is 4.8 grams. Okay? Uh, Let us perform some balanced equation. Some balanced equation. Okay. Suppose that we have this reaction. Suppose that we have this reaction. C4H10. This is a gas. Plus O2, come in, this is a gas. Under a combustion, it will give carbon dioxide. This is also a gas. Plus water vapor. This is also a gas. And we have to balance. Okay, we have to balance. If you have, first of all, note this remark. We should keep balance oxygen till the end because oxygen is an element, and we are free to multiply it by any number it is required. First of all, we have C4, we have C inside. The formula N, we have one carbon. What should multiply 1 to be 4? We should multiply it by 4. Okay? Hydrogen is 10. What should we multiply it by? To get 10, we multiply it by 5. Okay? Finally, we can write it as X here. 2X should be equal to the other side. How many oxygen N we have? N we have 2. Multiplied out by 4, so we get 4 times 2, it is 8. In the other formula, we have inside a formula 1 multiplied by 5, we get what? We get 13. Okay? For that, then X is equal to what? Equal to 13 divided by 2. We write it again. Then again, we can write it again. Okay. Then we have C3H upon C4, C4, H10 plus. Instead of X, we write 13 over 2 oxygen gas. And we get what? 4CO2 plus 5H2O. If we don't like the fraction, we can get rid of the fraction by multiplying all the equation by 2. Okay, this is a balanced equation. It's true if it is. If you have to keep it as it is in fraction, it's true. But if you get rid of a fraction, you can multiply. Okay, you can multiply it by, multiply this all. Multiply this all, the equation times 2 out. And 2 times what? 2 times 1 here, we get 2C4H10 plus second one, 2 times 13, 26 divided by 2, it gives 13. Continue. 2 times 4, 8 times CO2 plus 2 times 5, we get 10, 10H2O. This is the other form of the balanced equation without a fraction. This is a true balance, and this is also true balance. Okay, let us take another equation. Let us take another equation. Second example. Second example, suppose that we have C4H10O plus O2, we get CO2 plus H2O, and we have to balance it. A little bit complicated. And if we have 4 now, carbon as usual, carbon, okay, carbon we multiply out by 4. 5, 10 here, 2 multiplied by 5 to be 10. Oxygen. Here we don't have only one source of oxygen, we have two sources. This is one source, one oxygen plus. Here we have, let be x. X times 2 equal to what? 4 times 2, it's 8, plus 5 times 1, it's 5. The answer will be 13. Solve this equation of one unknown. You can solve it. 2x, here we have 2x plus 1 equals 13. Mathematically, we write 2x equals 13 minus 1 is equal to 12. What will be x now? 12 divided by 2 equals 60. Okay? We rewrite here, we don't have fraction, we rewrite it again. How we can rewrite it again? Write finally C4H10O plus 6O2 to get what? To get 4CO2 plus 5H2O. Okay, and then we apply balancing equation on the law of conservation of mass. We have a lot of equation. We can do it. Okay. Now let us take a second form of balancing. Okay. What is the second form? Suppose that you have application. Okay. No. هناخد واحد تاني application, another form of balancing the equation. Our second form is consider, okay, consider هيدا مثلا هناخد هيدي الكلمة consider the following balanced equation. أخلي لهذا المثل وأعطيك مثل تاني. We have here 2, we have here 18, we have here 25, and we have here, okay, that's it. The answer, okay, calculate x and y. Calculate x and y. Calculate x and y. Then write the equation. Then write the equation of the reaction. Okay. Equation of the reaction. Okay. What do we have to say? We say, according to the law, this is a balanced equation. Now, okay, we have to calculate x and y by applying the law of conservation of law. We write, according according to Lavoisier's law, or it's better to write conservation of mass, according to the law of conservation of mass. according to the law of conservation of mass or atoms in a chemical reaction of mass. What do we have? First of all, we have carbon atom, we have hydrogen atom, and we have oxygen atom. Okay? We have, you can start like that. Do you still are, do you see now? بعدك شايفة نوى؟ Okay. أروح. طيب نوى نوى where are you نوى؟ نوى I'm not hearing you. Okay, we continue. Then we have this equation, we go say by law of conservation. She's out. By law of conservation of mass, let us apply this law between reactant and product. Carbon and reactants, we have 2 times X. In reactant, we have 2 times X. Two X is equal in reactant is 2X. In a product, also we have 2X. Okay. Then this way don't have any advantage of it. Hydrogen, what do we have in hydrogen? We have, on this side, we have 2 times 18. For reactants, 2 times 18, it will be equal for product y times y, at y times 2. Y times 2, if we have to solve this, we say that y equal 2 times 18 divided by 2. So say that y is equal to 18. Finally, to find x, we go to oxygen atoms. Oxygen atom, what do we have oxygen atom? How many oxygen atom we have on the reactant side? Multiplied out, 25 is out, 2 is in. We multiply 25 by 2. 25 by 2 should be equal to what? To 2x. 2x times 2, 4x, for first 4x, plus, here we have n, 1 times y. What will be x equal to? 50 equal to 4x plus y, which is what? It's 18. Replace y by 18 and solve. 4x equal to 50 minus 18, we get 32. What will be x equal to? What will be x equal to? We divide 32 by, then x is equal to 32 divided by 80 by 4, we get 8. Finally, the equation will be, this equation will be replace, instead of x, put 8. Instead of y, 2 times 8 is 16. Instead of y, put 18. And we get finally a balanced equation. Okay, this chapter, this period now is almost finished. Okay, next time we will continue. Okay, I will send you the video and the document.